Okay, all right, so we have a table of values, and we've got different functions here, and it wants you to evaluate each of these particular derivatives when x is 2. When x is 2. So they better give us enough information, and I guarantee you they do, for us to be able to do it. So here's the deal. So if h of x is equal to this composition, f of g of x, then h prime is going to equal f prime, copy, in terms of the inside function. So I just copy that all in there, and this will be g of 2 in just a second. And then chain rule, bleep. So chain rule is g prime of x, all right? So I'm doing this for 2, all right? So h prime of 2 then would be f prime g of 2 and then g prime of 2. And they better give us all these values. Okay, so first thing, it's going to be f prime of g of 2. All right, so here's g of 2 is 3. All right, and I'm looking because I know I'm going to need that 3. That 3 now becomes our x value for f prime. And while we're here, g prime of 2 is -1. Okay, and then f prime of 3, which thank goodness they gave us that value, otherwise we couldn't do this, is -2. And so I've got -2 times -1. And there we go. Okay, now, so for this one, and this time I'll go ahead and use the using x is 2. So k prime of 2 will equal, all right, and this is a power rule, so it's 3 times f of 2 squared. That's power rule. Chain rule. You don't have to draw the arrow. I just like to. F prime of 2. Okay. So once again, hopefully we're given all of these values so we can actually do this. So this is 3 from the power rule. F of 2, all right, f of 2 is 8. All right, 8 squared is what that's wanting us to do. And then f prime of 2, nope, I just messed up. That's not 8. F of 2 is -4. -4 squared. F prime of 2 is 8. Okay. So we have 3 times 16 times 8. So 3 times 16 is 48, and 48 times 8, 384. So 384. Okay. All right. A and B, I'll have those be a separate video, and I'll put C and D next.